This is going to be a short video explaining how to do one of the harder exercises in the 1.3 Aplia assignment set. And that's exercise set 6. This is going to be an exercise where it's going to give you an argument, and the first thing you have to do is to figure out whether it's deductive or inductive. And hopefully from the earlier exercises that you've done, you're going to be able to do that pretty quickly. I'll talk about some strategies in this video about how to do that. And then after you've given whether it's deductive or inductive, you have to correctly identify what type of deductive or inductive argument it is. And there's something like 12 or so to choose from, and so I'll talk about how to approach that as well. So let's take a look at argument A that they give us here first. Ryan will either pass his logic class or he will fail. All right. It is certain that he will not fail, therefore Ryan will pass his logic class. All right. So this is going to be an example of a classic kind of deductive argument. One where if those premises were true, sort of by language, that conclusion must also be true. Right? If he's either going to pass or fail, and we know he's not failing, therefore he's going to pass, that's got to be a guaranteed conclusion, given this particular claim here is the idea. So I'm going to do deductive. All right. Ryan will either pass or he'll fail, and he's not going to fail, therefore he must pass. And that's going to be what's called an disjunctive syllogism. This is going to be a case where I just have two premises. I say it's either A or B, and one of those things is false, therefore the other thing has to be true. That's a classic example of disjunctive syllogism that we have here. Okay, let's look at argument B then. Since Flipper is a dolphin, it follows that Flipper is a mammal. All right, so this is one where it's kind of weird, right? Because it looks like, well, there's just one claim here. Is this even an argument? And if we do a little bit of unpacking and we do a little bit of charitable interpretation of what is happening here, yeah, we're going to call this an argument. And it's one that says, because Flipper is a dolphin and all dolphins are mammals, that's the sort of implicit premise that's missing here, but's implied, then it must follow that Flipper is a mammal. So this is going to be what's called a deductive argument because, given the language, given the definition of dolphin and mammal, that because all dolphins are mammals and Flipper is a dolphin, it must follow that Flipper is a mammal. There's no way to avoid that conclusion if those premises are true. It's not probabilistic, it's just guaranteed. And this is what's going to be an argument based on definition, right? It's the definition of the terms that really generate the certainty of the conclusion. All right, let's look at argument C. Mount Dana and Mount Whitney, I guess these are two mountains, yep, are both in the Sierra Nevada range. Since there is wildlife living above the tree line on Mount Dana, we can conclude that there is also wildlife living above the tree line on Mount Whitney. Okay, so imagine somebody is giving me this argument, right? And they've given me this conclusion where it seems like, hey, we're super confident, right? We're 100% confident that because there's wildlife above one tree line, that means there's got to be wildlife above this other tree line. But if I'm being logical about this, I should recognize, hey, just because there's animals above this mountain's tree line, that doesn't guarantee there's or animals above this mountain's tree line, because maybe they're different sizes, right? All we know is that they're in the same mountain range. And within a mountain range, you could have lots of different heights for mountains. So this conclusion, if it's going to be anything, has to be probabilistic, even though it's worded like it's supposed to be guaranteed. I should look at that and recognize, hey, that's only likely given the premise. That makes it an inductive argument, right? If the conclusion is only likely, even if it's like 99.9% likely, it's got to be an inductive argument rather than deductive. Deductive arguments have to have 100% guaranteed true conclusions. Okay, so it's inductive, and I've got to figure out, well, what is it then? Am I making a prediction? Well, in some sense I am about what's happening above this tree line, but that's not really like, I'm not looking at the past and making a prediction about the future based on that. And though I'm making a sort of prediction about what is going on at Mount Whitney, what is really happening is that I'm trying to compare Mount Dana here to Mount Whitney and saying, well, they're like the same. There's an analogy between the two, right? That because one is like the other, then by analogy they should have this same characteristic of having wildlife. So what this is going to be is an argument from analogy, where I'm saying because two things are similar, what's a characteristic of one of the things, Mount Dana, should also apply to the other thing, Mount Whitney. Okay, and then this last argument, a survey of 10 evolutionary biologists reveals that 7 of 10 believe in a divine being. Okay. From the survey, we can conclude that 7 out of every 10 evolutionary biologists across the country believe in a divine being. All right. So this one, like the last argument we saw, gives us a conclusion where they're being overconfident. They're like, hey, yeah, this is definitely the case, given the limited amount of evidence that we have. But what I should be thinking here is, wait a minute, it's not guaranteed that just because 7 out of these 10 believe in a divine being, that means all cases where I've got 10 evolutionary biologists is going to yield the same result. This is a statistical sample, And so I have to recognize any conclusions I draw from it have to be statistical or probabilistic themselves. The conclusion is only probable, given this evidence. All right, and then I have to figure out, well, what have I done here? Was it an analogy like the one before? No, I'm really reasoning from a sample. So let's see if we can get something like that. Argument from definition, no. Signs, no. Authorities, no. I'm not saying the authority said it, that's why it's the case. I'm using some sort of sample, or in this case, I might also think about it as a generalization to generate this conclusion. All right, I'm saying, look, generally, this was the case here, therefore it's going to apply to all cases. That's a sort of standard generalization move.